Two walls of a room need to be painted. To estimate the amount of paint required, the number of square feet of wall space needs to be calculated. One wall is 12 feet long and the other is 20 feet long. Both walls are 9 feet tall, and we're told to neglect any windows or doors. Compute separately the area of the two walls. Find the total area by adding the two areas. So if we call this region, I'm going to call this region 1, and I'm going to call this region 2, then the area of region 1, just length by width, or width by height, however you want to think of it, the area of region 1 would be 9 times 12, which is 108 square feet. And then the area of region 2 would be 9 by 20, which is 180 square feet. And so then the total area would be the area of the first region plus the area of the second region. And so that would be 108 square feet plus 180 square feet. And so that would be 288 square feet. So there's the area, 288 square feet. Exercise B tells us to consider the two walls to be one large wall. First, compute the total length, and then find the total area of the two walls. Well, the total length, so let's see, the total length would be, 12 and 20. That would be the total length. So the total length would be 12 plus 20, that would be 32 feet. And so then the area would be that total length times the height, so we would have 9 times 32, and that would be 9 feet times 32 feet, and that's also 288 square feet. So it turned out that we could either multiply first or add first. So these calculations were an example of which property? So here's what we saw. 9 times 12 plus 20 was the same as 9 times 12 plus 9 times 20. In other words, if we added first, that would give us the 9 times 32, which was 288. Or if we multiplied first and then added, it gave us the same thing. And this is an example of what's called the distributive property.